Hello everyone. In this video, we are going to use a complex topic to solve a complex question, but this complex topic is going to make that question an easier one. So first let us see the language of the question. A positively charged particle travels through a uniform electric and magnetic field. They are perpendicular to each other. At one point in time, its velocity is represented by V0 bar, with V0 being perpendicular to both E bar and B bar. So fields are perpendicular to each other and V bar is also perpendicular to these two. So V0 bar, E bar, B bar are mutually perpendicular vectors. Assuming that E is going to be equals to V0 into B, let the velocity of the particle after some time is V bar is equals to minus P0 into V bar, when its velocity vector makes an angle of 180 degrees with V0 bar. P is a dimensionless number. What is the value of P here? See, in NCERT you will be seeing this velocity selector kind of concept where E bar, V bar, B bar are mutually perpendicular to each other, where force due to electric field and magnetic field will cancel out with each other so that particle will move in a straight line path. But in the question it is clearly visible that V bar is anti-parallel to V0 bar. So it is not a question of velocity selector definitely. Now it is turning, means the net force on the body is not going to be zero. Velocity is changing there. Acceleration is there and net force will be non-zero quantity. So before entering into the actual solution of the question, I want to discuss a few points which we are going to use in the solution of this one. That is field transformation. If E bar is the electric field and B bar is the magnetic field in the inertial frame, or you can say ground frame, then that electric and magnetic fields will vary from a frame of reference to frame of reference. If there is a frame which is moving with a velocity of V0 bar, then the electric field in that frame will be given by this expression. E dash bar will be is equal to E bar plus V0 bar cross B bar, and B dash bar magnetic field in that frame will be B bar minus this quantity V0 bar cross E bar divided by C bar. Right, this is how the field will transform in a moving frame. And here I have written one more term, VD bar is equals to E bar cross B bar by B square. What is this VD bar? Now let us assume the frame is moving with this much velocity. Then what will be the electric field in that frame? So I am just, instead of V0 bar, I am going to substitute this value. I have done this here. Now this is a triple product. I am going to expand this triple product. E bar dot B bar into B bar, that is this, minus B bar dot B bar into E bar divided by the denominator B square. Now I am specifically discussing about this question where they have given that the fields are mutually perpendicular to each other. So if E bar and B bar are perpendicular to each other, then their dot product will become 0. So this you can neglect. Then B bar dot B bar is going to be equal to B square. So this B square gets cancelled out. Then you can see what is happening when the frame is moving with that particular velocity. The electric field in that frame is becoming 0. So why we have to concentrate on this frame? You can see. Now we will go into the actual question. There I will explain you why we are going to concentrate on that particular frame moving with this particular velocity where the resultant electric field is becoming 0. Right. So I am assuming that velocity is in x direction, magnetic field is in k cap z direction. So we all know magnetic force acting on the charged particle is given as Q into V bar cross B bar. I cap cross k cap will be along minus j cap. So the magnetic force acting on the particle is going to be along negative y axis. For the turnaround, here E bar have two options. I have taken velocity along I, magnetic field along k. Means electric field can be either along j cap or it can be along minus j cap. If it is along j cap, then the electric force and magnetic force will get cancelled out and it will move in a straight path. But that is not our question. There is a turnaround. So when there will be a turnaround, The electric force should not balance the magnetic force. Instead, it should act in the direction of magnetic force. So that's what I have written here. For the turnaround, Fe bar should not cancel out B bar. So Fe bar is taken in the direction of magnetic force, that is minus V naught B J cap, minus J cap direction. Now what I am going to do is, instead of seeing it in ground frame, I am going to see the motion of the particle in a frame which is moving with this particular drift velocity. Why this frame? If you ask, in the ground frame there is a magnetic force, there is an electric force acting in this direction. Path will be a little bit complicated. But when I see in this frame, as I already told you, when you are moving this particular velocity, when E bar and B bar are perpendicular to each other, then the net electric field in that frame is 0. So in that frame, particle will not experience any electric force. If there is no electric force, you are left out with only magnetic force, which is a very simple case. When there is a particle moving perpendicular to a magnetic field, it will be in a uniform circular motion, right? So first let us calculate that drift velocity, right? So drift velocity Vd bar, you substitute the E bar equation what they have given here, minus V naught into Bj cap. You can take the cross product. You will be getting this B square cancel out. Minus J cross K will become minus I cap from there. So this is the particular velocity with which I have to assume a frame from where I don't experience any electric force. We experience only magnetic force in that particular frame. Now, what is the velocity of the particle moving in this frame at t equal to 0? So I want to know what is the velocity of the particle in that particular frame. That is velocity of the particle minus velocity of the frame. So this is V naught I cap according to our assumption, and this came out as minus V naught I cap. V naught minus of minus V naught will become 2 V naught I cap. So as I told you, in that frame we experience only magnetic force, due to which you experience only the uniform circular motion of the path. So motion in the drift frame, initially it is having a velocity of 2 V naught. When it turns around, it will be having a velocity of minus 2 V naught I cap. UCM, no speed will be remaining constant there. Magnetic force will not do any work on the particle. The speed is remaining constant. Direction just changed to from I cap to minus I cap. So this is the velocity of the particle in the frame which is moving at that particular velocity Vd bar after the turnaround is completed. But the question is not about this frame. Question is about the ground frame. So I want to know what is the velocity in the ground frame. So simple relative velocity concept. Velocity in a particular frame will be velocity in the ground frame minus velocity of the frame. So you can take this Vd bar here. V dash bar is minus 2 V naught I cap. You can substitute. Vd bar is minus V naught I cap. You can substitute. Total you are getting it as minus 3 V naught I cap. So in the ground frame it is having a velocity of 3 V naught I cap. According to the question, they have given it is minus P V naught bar, which is going to be indicating the value of P is 3 here. Thank you. Hope you will understand this question. We will come up with